Good afternoon, students. We will start with the numericals part 2, that is the numericals covering the displacement time graph we have done, then velocity time graph. Okay, it's actually mixed. Actually, you will get displacement time graphs also in this part, but mostly velocity time graph. Okay, so this is a second set of numericals which we will be doing now. So I hope you have gone through the numericals from displacement time graph only, which I have sent earlier. Now see the first one. Given the displacement time graph, ST means S stands for displacement. So this one is already given to you. This is not given. This table is also not given. It is asked to calculate the velocity at t equal to 1 second, 2 second, 3 second and then draw the VT graph. Now, I hope you know how to find the coordinates of a point. Say, I just made the table. I wrote t equal to 0, t equal to 1, t equal to 2, t equal to 3. Now S and V. S stands for displacement, V stands for velocity. See, at t equal to 0, S is 0. T equal to 1, see, t equal to 1, displacement is 2. So if displacement is 2, velocity will be 2 by 1, 2, because velocity is displacement by time. T equal to 2, t equal to 2, how do you find this? If t equal to 2 means this one, this t equal to 2 corresponds to which value in the displacement axis? 4. So t equal to 2, 4, S is equal to 4, so V is 4 by 2, 2. Again see t equal to 3 corresponds to which value? 6. 6 by 3, 2. So see, from 0 to 1 second it has increased to 2 meter per second velocity. After that it was constant. See, no change in velocity, uniform velocity. So just can you see, uniform velocity graph for displacement, uniform velocity, displacement time graph is this, and this part corresponds to the uniform velocity for velocity time graph. Now, next one. In this case, this is given. Velocity time graph is given. You have to find displacement time graph. So this was given. I just made the table, same case, same like the previous one. T equal to 0, 1, 2, 3, 4. V equal to 0, sorry, t equal to 0, V is 0. T equal to 1, V is 1. T equal to 2, V is 2. 3, this is 3. 4, this is 4. So I've written these values, then I've written these values. How? Simply just multiply. Velocity into time will give you displacement. So 1 into 1, 1, 2 into 2, 4, 3 into 3, 9, 4 into 4, 16. Can you see the displacements? These are changing non-uniformly. So, non-uniform velocity. This is the graph for non-uniform velocity. This is the graph for displacement time graph for non-uniform velocity. And this we have already done non-uniform velocity. This velocity is changing but uniform acceleration. So don't mix up with what is changing and what is constant. In this case, non-uniform velocity, that means velocity at each point is changing. So, and actually why? Because displacement, it's not changing uniformly throughout. See the changes, not equal change in displacement in equal interval of time. Okay. So basically this graph was given. I have drawn this graph with the help of the values. Now moving on to the next one. See, the graph is given to you. First question, label, see number 9, okay? Label the different parts as which category of motion. That means AB, BC, CD represents which categories of motion. AB will represent Uniform acceleration. Why? Velocity is changing, but see, uniformly. This graph represents uniform acceleration, non-uniform velocity, but uniform acceleration we have done. So uniform acceleration. What about this one? Velocity is constant, so uniform velocity. Uniform retardation, because negative slope. Compare the magnitude of acceleration and retardation. Acceleration in AB part, the slope of AB will give me the acceleration. So in t seconds, what is the change in velocity? V0 minus 0 by t minus 0, so V0 by t. And what is the retardation for CD part? C. Change in velocity is 0 minus V0 because it is decreasing velocity. By change in time, 2.5t minus 2t. See? So why have I not used minus sign? Because I am writing retardation. If I have written acceleration, then I would have used minus this. Now minus, say minus 20 meter per second square means retardation is 20 meter per second square. So which one is greater? Obviously the magnitude of retardation. Why? Because see, the denominator is less in this case. Now we will have to compare. Compare means we have to find the ratio of acceleration is to retardation. Simply divide this V0 by t divided by V0 by 0.5t. I have done the division and I have got 1 by 2. So the ratio is 1:2. Now see number 10. Again same type of graph. See, AB represents non-uniform velocity, that means velocity is changing but uniformly, so uniform acceleration. Uniform velocity, uniform retardation. Now you have to find acceleration in AB. Same thing, just like we have done AB acceleration, that means in 4 seconds. What is the change in velocity? This by this. 30 minus 0 by 4 minus 0, 7.5. And BC, obviously no acceleration because velocity is constant, change in velocity is 0. CD, what is the retardation? Minus 15 meter per second square. Same thing I have calculated, just like the previous case. Now, displacements you have to find. For AB, what is the displacement? Area under this area of this triangle. Because for AB, this is the velocity times sketch. You have to find the area. It has covered between, it has enclosed between this and the x-axis. So only this part doesn't come here. It's about only AB. So the triangle, so area of a triangle, half into base into height, half into 4. See the base, AO is the base. Into height is BO. So I have done that. What about BC? BC part. That means the area enclosed by this graph, this sketch and the x-axis. That means, see the rectangle. BCPO rectangle. Why? Because we won't consider neither this part nor this part. Because only how much area this BC sketch is enclosing with the x-axis. So we'll drop perpendiculars to just mark the boundaries, okay, of the area. So you'll get a rectangle. Base, so it's just length into breadth. So simply 4 into 30, 120 meter. Then CD, again area of the triangle, half into base into height. So half into this much is 10 minus 8 to 30. What is the total displacement? You have to add these 3. An alternate method is simply you could have, instead of finding individually AB, for individually finding this area and this area, simply just see ABCD. ABCD, isn't it a trapezium? ABCD is a trapezium. What is the area of a trapezium? Half into sum of the parallel sides BC plus OP BC is how much? 4. If this is 4, this is also 4. So 4 plus 4, 8. Half into 8 into the height of the trapezium, or the distance between the parallel sides, that is 30. Okay. BC is 4. I have said BC is 4 plus this one. For the trapezium ABCD, what is the area of trapezium? Half into sum of the parallel two sides, BC plus AD. BC is 4 and AD is 10. So 4 plus 10, 14 into the height. So I have done that only. Sorry, I just by mistake said. Okay, it's BC plus AD. Now see this one. Again, this graph is given. Question is nature of motion for AB. See, for AB, same thing again. Non-uniform velocity but uniform acceleration. That means velocity is changing uniformly. What about BC? Uniform retardation. So 0 to 4 seconds, see, up to 4 seconds, uniform acceleration. From 4 to 6, this part, uniform retardation. So next is displacement at 6 seconds. Displacement at 6 seconds. That means basically you have to find the area of triangle ABC. Displacement after 6 seconds, total area. If I have asked you displacement after 4 seconds, then area of ABO. Displacement between 4 to 6, BOC. But the question is displacement after 6 seconds. So, area of ABC, that is half into base into height. Base is 6, height is 2. See? Now compare the distance traveled. See the question which I just said. And what did I say? The question is compare the distance traveled from 0 to 4 and 4 to 6. Since the whole thing is above the time axis, so distance and displacement same. But if it was below, then distance and displacement would have been taken considering the signs. So distance, displacement same. 0 to 4, just now I said area of ABO. And 4 to 6, area of this triangle. Find the area and then find the ratio. Next question is you have to find the accelerations 0 to 4 and retardation 4 to 6. Obviously 0 to 4 acceleration will be change in velocity 2 by 4. See? And retardation, I hope you can make it out from the graph only now. Just that it's negative slope, that's why. If it's minus 1, I have calculated acceleration so that I can get minus value and I can simply write retardation as 1 meter per second square. Now see this one. A ball moves on a smooth floor in a straight line with uniform velocity 10 meter per second for 6 seconds. Okay. Now at t equal to 6 seconds, that means the ball is say moving like this. After that, it hits the wall and again bounces back. Then how will we draw the graph of velocity time? Let's first just, if you face any difficulty in drawing the velocity time graph first, we can actually start with the displacement time graph. See the displacement time graph, what will it be? Initially it's moving with, uniform velocity, right? Because it has been mentioned. For 6 seconds at a uniform velocity of 10 meter per second. So this will be the displacement time graph for when the ball is moving from say the start point till it hits the wall. Then what has happened? It changes its direction and it now moves in the opposite direction towards the starting point. Negative slope of velocity. It starts moving in the opposite direction. From where it has started, now it will start moving towards that direction. So, if you draw this, then you will be able to figure out the velocity time graph. See, for this part, what will be the velocity time? For 0 to 6, uniform velocity, so 10 constant. And from 6 to 12, negative slope. So we are marking minus 10. This minus 10 denotes moving in the opposite direction. Understood? So, how will we find the displacement? First, let's find the what is the total distance? It's very easy to find. Displacement also, just you have to take care of the signs. See, above the time axis, positive, negative. That's because of this fact. Displacement here, it's in the opposite direction. That's why. What is the area? What is the area of this part? Simply this into this. So 6 into 10, 60. For this, minus 60. Right? So, net displacement after, if I ask after 6 seconds displacement, 60 meter. But after 12 seconds, 60 minus 60, 0. Because see, if you just follow the displacement time graph, you will be able to understand if the particle comes back to the same point where it has started, this is time axis. And at t equal to 0, s is equal to 0 from where it has started, t equal to 12, sorry, s is equal to 0, that means the point where it has started, same, it has returned to the same position, so displacement will be 0. So now can you picturize why from the displacement time graph we just add with the proper sign so that we get the proper displacement with the proper directions. So we are getting 0. Now what is the distance? Simply 60 plus 60, 120 meter. You don't have to consider the signs because distance is the total length of the path covered. Does not need any direction to be specified as it's a scalar quantity.